So what we can say here then, if the measure of angle D right here is 60 degrees and this is 40 degrees, what side is longer? What side is longer? It's got to be the side opposite. So yes, it's FE. See, this angle is bigger than this angle, so we go to the side opposite. So this side is bigger than this side. That's all we know, okay? We don't know anything about DE. I'm assuming it's the longest side, but we can't always assume. We have to only go with what we've been given, okay? If the measure of angle D is greater than the measure of angle E, then EF is greater than DF. What do you think of that? Basically, that's what you're going to be working with in 4.7. So, list the sides and angles in order from largest to smallest. Okay, so what side is the biggest side?
PR.
PR, right? So that means that Q is the biggest one, correct? And I'm going to go from largest to smallest. Angles. So I can say that angle Q is the largest angle. And then what's next? What's the next biggest angle? P. Yeah, because 8 is the next one. So then we're going to go here. And then angle P. This is from largest angle to smallest angle. And then angle R. So you could say first, second, third, if you want to do it like that. Yeah? Got it? Okay. Now, sometimes you might want to fill in this angle. How could you do that? Find out the angle measure for E.
180.
Exactly. I can do 180 minus 110 minus 37 will equal angle E, which is going to equal 33 degrees, if I do that math. It's 33 degrees. So I'm going to put 33 in here. Now they're giving me the angles, which means I have to order the sides, correct? I wouldn't order the angles because that's what they're giving me. I have to order the sides. So from largest, again, largest to smallest. What's the longest side? Yeah. This is the first one, DE. And then what's the next one? Yeah, this is the second one, EF. And then the third one is the side opposite, 33 degrees, which would be DF. That's doable, yes? Okay, turn the page. All right, name the largest and smallest and largest angles of the triangle. Again, we have to figure out what angle E is simply by doing the math. So let's just do 180 minus 103 minus 32. And it equals 45. So we kind of know that now, but if we didn't know that, let's look at the sides here. This is 18, this is 24. Let's look at what we've been given, rather than knowing that this is 45 degrees. I know that this is the biggest angle. How do I know that? How can you tell? Because it's what? Yeah, but it is the biggest number, but let's go more by what we know about triangles. What do we know, Lily? It's obtuse. There can only be one obtuse triangle in an angle in a triangle, correct? Can you have more than one obtuse angle in a triangle? What does obtuse mean? Greater than what? 90. So this has to be the longest side based on your knowledge that there can only be one obtuse angle in a triangle. Okay, so that has to be the longest side. So that has to be the longest side. Then we have 18 here. So that means that this is the 18. I don't know. Angle D has to be the smallest. How do I know that? What do you think? Does anybody have any suggestions? No? And it's smaller than this? Okay, so I know that this is going to be bigger than what? It's going to be bigger than 24, isn't it? Get that? This is going to be bigger than 24, correct? And then this is the next biggest one, and this is the next biggest one. Can you kind of dissect this picture? Stop and look at it. I know that this is going to be bigger than 24, which is bigger than this, which is bigger than this, correct? Get that? Okay, that means that the angle opposite this side has to be the smallest one. Let me say that again. I know because this is the biggest angle, this has got to be bigger than 24. This is the longest side, okay? Then this is 24, and this is smaller than 24. So this is the smallest side, therefore the angle opposite has to be the smallest angle. See how you kind of use that process to figure that out? Takes a little while. Angle D has to be the smallest. Because, that stands for because, DE is the longest, then DF, based on the angles, and then the side opposite, so the side opposite, EF, excuse me, the angle opposite, EF, has to be smallest. Takes a little logic, but you can do it. All right, name the shortest and longest sides of the triangle. What's the shortest side? EF. Shortest is EF. Again, we know that because this side has to be bigger than 24, then this is 24, and then that's 18. And then the longest is what? DE. Okay? Triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. In symbols, we can say here for this triangle, CB plus AB has to be greater than AC. If I add these two sides together, they will always be greater than the longest side. I could also flip the order of the letters. It doesn't matter. It's the same as saying AB plus BC is greater than CA. I'm saying the same thing. I'm just naming the sides slightly differently. Same as BC plus CA is greater than AB. I don't think that one's right. That one's not right. 5 plus 6 is not greater than 12? No. So no, it's not a right triangle, or not a triangle. I'm not saying right triangle. Let's try this one. 1 plus 2, is that greater than 3? It's not. It is. Well, no, we aren't squaring, Garrett, so we can't say that. Okay, so this is not true. 3 is not greater than 3, so no. Okay, so basically what you're doing in this section is just this right here, determining the longer sides, the bigger angles, and using this inequality theorem. Okay? All right. A segment from a vertex to the midpoint, I'm going to shorten midpoint, of the opposite side. Just for the heck of it, I want you to draw a triangle up here. Put little dots on each corner. The corners called, what are the corners called? Vertex. Corners are called the vertex. This is the midpoint right here. Midpoint. If I draw a line from this vertex to the opposite midpoint, it's called the what?
Centroid.
No, right here.
Median.
Median. It's called the median. So that's a picture of the median. And there's 3 of them. 3 medians in a triangle. The centroid is the point in the center where all 3 medians intersect. That was your P in your triangle. That was your P. The centroid is the point in the center where all 3 medians intersect. Okay? All right. Centroid theorem. I'm going to fill in this picture here in just a minute so we can kind of get what we're talking about. First, I want to do the writing. The centroid, this is the theorem, is always 2/3 of the way from the vertex to the midpoint of the opposite side. Let's fill in this drawing. First, I want you to do these little dots on each side. Those are the vertices or vertexes. However you want to, the vertices is the proper word. Now, very carefully, try and visualize the exact midpoint here. I'm just going to say it's about right here. And then I want you to draw as straight a line as you can from here to here. If that's the midpoint, then isn't this side this congruent to this? If that's the exact midpoint, then these 2 pieces are equal, correct?
Yeah.
All right, let's do this again then. Try and eyeball the exact center of that segment there. And then try and draw a straight line over here. You're drawing the medians is what you're drawing. If this is the midpoint, then I'm going to say these 2 segments are congruent, aren't they? Do the same thing for this last side. Try to eyeball the exact center, and then make sure your line, your median, goes through this right here when you're drawing it. So you have 3 medians now. And then, of course, this piece and this piece are congruent segments if that is the midpoint. This right here is called the what? Yeah, P is the centroid. That's what you can balance your triangle on, the centroid. P is the centroid. Now there's one more thing I want you to add on here. When I was showing you Garrett's triangle, I was telling you that if you look at one of these medians, the distance from the centroid to here is going to be what fraction? This is 2/3 of that median. This is 1/3 of the median. It's like you divide it into 3s and 2 of the parts go here and 1 of the parts are here. That's 2/3, correct? Each third. Here, this is going to be 2/3. This is 1/3. And then this last one, this is 2/3. This is 1/3.
So it's a 2/3, 1/3 add.
Yeah, because 2/3 and 1/3 add up to a whole, correct? All right. So we got to use that to answer these questions here. So G is the centroid. So they're telling you that's exactly in the center of triangle ABC. AD is 8. All right, so they labeled that already. AD is 8. AG, that's from here to here, is 10. And CD, this whole thing right here, is 18. Find the following. So I need to know BD. Based on the information they gave me, do I know what BD is?
Yes.
What is it? 8. Because remember, this is the exact midpoint of this side. If this is 8, then that's 8. Yes? You with me? Okay. AE. I need to know AE from here to here. They're telling me that AG is 10. What do you think you could do to figure out this total thing? Remember, this is 2 parts to 1 part, right? 2 parts to 1 part. Let's cut 10 in half. What do I get if I cut 10 in half? Okay, so if I say this is 5, this is 5, what do you think this piece is? 5.
What?
See, I cut it into thirds, didn't I? This is 2 parts to 1 part. 5, 5, and 5. That means the total is 15. Do you understand how I came up with that? Yeah, this segment is 10, yes? And I know that this is 2/3 and 1/3. So this is 2 parts and 1 part. So I cut this in half. Okay? And then CG, the last one I need to know, is from here to here. How can I use that? Yeah, this is going to be 12 because the total thing's 18. 6, 6, and 6. 12.